Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about normal distribution. So what is the definition of normal distribution? The normal distribution definition is, if x is a continuous random variable, x is a continuous random variable and mu comma sigma square are any two parameters. Mu comma sigma square are any two parameters. Then the normal distribution is given by n of mu comma sigma square, that is equal to p of x1 less than or equal to x less than or equal to x2. That is equal to r p of capital X1 less than or equal to capital X less than or equal to capital X2. That is equal to, the formula is 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. So this is our normal distribution formula. This is equal to f of x. So f of x equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. Okay. So here capital X is a continuous random variable, but binomial distribution and Poisson distributions are discrete random variables. But the normal distribution is continuous random variable. Okay, so what is discrete random variable and what is continuous random variable? So discrete random variable is nothing but if the range of random variable is finite, then we can say that is discrete random variable. So what is continuous random variable? If the range of random variable is infinite, or the range of random variable is interval of two real numbers, then we can say that is continuous random variable. Okay, so the normal distribution, in the normal distribution here x is a continuous random variable. That means here we have to use integration. Okay, so then the normal distribution, the main formula is f of x equal to Rn into mu comma sigma square. That is equal to p of x1 less than or equal to x less than or equal to x2. That is equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square, where minus infinity less than or equal to x less than or equal to infinity. Okay, so let z equal to x minus mu by sigma in normal distribution. So let z equal to x minus mu by sigma in our normal distribution, then that will be n of z, that is equal to p of z1 less than or equal to z less than or equal to z2, or probability of capital Z1 less than or equal to z less than or equal to capital Z2, that is equal to 1 by sigma root 2 pi, we have to write as it easily, and e power minus 1 by 2 into, what is the z value? Z value is nothing but x minus mu by sigma. Okay, so that's why this will be e power minus 1 by 2 into z whole square. That means 1 by sigma root 2 pi e power minus z square by 2. Where z is also same, minus infinity less than or equal to z less than or equal to infinity. So z is also lies between minus infinity to infinity, like that x is also lies between minus infinity to infinity. Now coming to the definition of normal curve. So what is normal curve? So this is very useful for doing the problems in normal distribution. So normal curve. So normal curve is, first point, the normal curve is bell shaped. The normal curve is bell shaped. So this is our normal curve. The normal curve is bell shaped and it is symmetric about x equal to mu and z equal to 0. So it is symmetric about x equal to mu and z equal to 0. It is symmetric about x equal to mu and z equal to 0. That means the area of left side area is equal to right side area. Symmetric is nothing but left side area is equal to right side area. Okay, so the third point, the most important point is here, the third third point is the total area in the normal curve is unity. The total area in the normal curve is unity. The total area in the normal curve is unity, and half of the area in the normal curve is 0.5. So that means half of the area is 0.5. This is 0.5 and this is 0.5, and the total area is unity. That means 1. Okay. So that means what is the meaning of this one is the total area is 100%, and this is left side area is 50%, and also right side area is also 50%. Okay. So what is normal curve? Normal curve is bell shaped and it is symmetric about x equal to mu and z equal to 0, and the total area is unity and the half of the area is 0.5. So x equal to here the normal curve at a symmetric about z equal to 0 means, so in the left side we have all negative values, that means -1, -2, -3 and so on up to -infinity, and z equal to 0 will be in the middle, and this is some 1, this is 2 and so on up to infinity. So here the normal curve is z equal to 0 means here -infinity to 0 is equal to 0 to infinity. This is only possible in the normal curve. So the normal curve at symmetric about x z equal to 0 means, so left side values are negative values and right side values are positive values. All left side values for z is negative values. All right side values of z is positive values. It is symmetric about z equal to 0 means -infinity to 0 is equal to 0 to infinity. So this is our normal curve. Next, note the total probability in the normal distribution is unity. The total probability in the normal distribution is unity. By the definition of normal distribution, n of mu comma sigma square, so that is equal to p of x1 less than or equal to x less than or equal to x2, that is equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. So that means that is f of x equal to p of x1 less than or equal to x less than or equal to less than or equal to x2, that is equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. Okay, so now we have to prove that the total probability in the normal distribution is unity. So that means in the normal distribution, this is continuous, no? Normal distribution is continuous. That's why we have to prove that the total probability means integration over -infinity to infinity f of x dx equal to 1. So we have to prove this is equal to 1. The total probability is equal to 1 means, so in the normal distribution, the x is continuous random variable. That means normal distribution is continuous, no? So that's why we have to prove that integration over -infinity to infinity f of x dx equal to 1. Okay, so what is f of x? So here f of x is 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. So now I am considering only this part. We have to prove RHS. Now I am taking only LHS part. We have to prove RHS. The LHS part is, okay, consider the LHS part. The part is integration over -infinity to infinity f of x dx equal to 1. So we know that f of x is this one. That means integration over -infinity to infinity f of x is 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square into dx. Okay, so now let us consider z equal to x minus mu by sigma. So from this x minus mu equal to sigma z. Okay, x equal to mu plus, you can take into that side, that will be x equal to mu plus sigma z or z sigma. Okay, so mu plus sigma z. So from this x equal to mu plus sigma z. Okay, so from that dx equal to, this will be 0. Dx equal to constant differentiation is 0. Sigma into this will be dz. Okay, so dx equal to sigma dz. So we know that x is from, these are the x values we are doing with respect to, we are doing the integration with respect to x. We are doing with integration with respect to x means here these are the x limits, right? So that's why x is from minus infinity to infinity. X is from minus infinity to infinity. If I substitute x value here, okay, so if I substitute x value here, that means x is minus infinity, then z is also minus infinity. If I substitute, so z equal to x minus mu by sigma is there. If I substitute x equal to minus infinity, then z is also, if I substitute minus infinity here, then z is also minus infinity. So if I substitute x equal to infinity, then if I substitute infinity here, then z is also infinity. Okay, so let x is from minus infinity to infinity. That means if I substitute x values here, then z is also from minus infinity to infinity. Now substitute all these values in the above equation. So then we will get integration over minus infinity to infinity 1 by sigma root 2 pi e power. So we have integration over minus infinity to infinity 1 by sigma root 2 pi into e power 1 by 2 into x minus mu by sigma whole square into dx. So this is our previous equation, right? So in this equation, we have to substitute all the limits. So z limits are x here, these are x limits, right? So we have to substitute z limits. Z limits are also same. So that's why that will be z is from minus infinity to infinity 1 by sigma root 2 pi e power minus 1 by 2. This is nothing but z square into what about dx? So dx is sigma dz. Dx is sigma dz. Sigma get cancelled, right? So that is, if I keep 1 by root 2 pi outside, then that will be 1 by root 2 pi. So our next step is integration over. So that is 1 by root 2 pi integration over minus infinity to infinity e power minus z square by 2 into dz. Okay. So after simplification of this one, okay. So here we need to check whether this function is even function or odd function. So we know that f of minus x equal to minus f of x. Then we can say that is odd function. If f of minus x equal to f of x, then we can say that is even function. So if I substitute z is minus 1, then that will be converted into f of z. So that's why, because here we have square, right? So that's why if we have z square means that is even term. So if that is even function, then f of minus z equal to f of z. So that's why this will be even function. If we have even function, so if we have even, if f of x is even, then we can write integration over minus infinity to infinity f of x dx can be written as 2 into 0 to infinity. Okay, so this is for even function. If f of x is odd function, integration over minus infinity to infinity f of x dx will be 0. Okay, just wait. So see, observe carefully. So this is our function, right? So this is our function. So e power minus z square by 2 is our function. So this is even function. Okay, so since this is even function, because f of minus x equal to f of x, then only we can say that is even function. If it is an even function, then so for even function, we can write integration over minus infinity to infinity f of x dx can be written as 2 into 0 to infinity f of x dx. So if it is odd function, integration over minus infinity to infinity f of x dx can be written as 0. Okay. So but this is even function. No, this is even function. So that's why we can write 1 by root 2 pi. This can be written as 2 into integration over 0 to infinity e power minus z square by 2 dz. So that's why I have written like this. 1 by root 2 pi, 2 into minus infinity to infinity can be written as 2 into 0 to infinity e power minus z square by 2 dz, since it is even function. Okay. Next, let us consider z square by 2 equal to t. Let us consider this z square by 2 equal to t. From that we can write z square equal to 2t and 2z dz equal to 2z dz equal to 2 dt. 2 get cancelled, and from this z dz equal to dt, dz equal to dt by z, dt by this z. Okay, so dt by z. So here we have z square equal to 2t, z equal to under root of 2t, right? So z square equal to 2t, from that we can find z equal to under root of 2t. So dt by under root of 2t, right? dz equal to dt by under root of 2t. So here these are all we are doing with respect to z, no? That's why these limits are z limits. Z is from 0 to infinity. So z is from 0 to infinity. So if I substitute z value here, so if I substitute z equal to 0, then z equal to 0, then t is also 0. If I substitute z equal to infinity, if I substitute z equal to infinity, then in this equation, then t is also infinity. So there is no change in the limits. If z is from 0 to infinity, then t is also 0 to infinity. Now substitute all these values in this above equation, this equation. So now that will be, so what about the above equation? First I will write here. So here, see, observe carefully. Here we have 2. 2 is nothing but root 2 into root 2. Root 2 get cancelled, right? So here we'll get root 2 divided by root pi into integration over 0 to infinity e power minus z square by 2 dz. Okay. So root 2 divided by root pi integration over 0 to infinity. So, sorry. Root 2 divided by root pi integration over 0 to infinity e power minus z square by 2 dt, right? So substitute the values here. Root pi integration over 0 to infinity. What about z square? We know that, yes, we know that z square by 2 equal to t. So we know that this z square by 2 equal to t. So that is e power minus t. What about dt? Sorry, what about dz? This is not dt, this is dz. So dz is nothing but dt by root t. dz is nothing but dt by root 2t. Root 2t. Okay, so I have written like this here. Root 2 by root pi. So this one. Okay, so after substituting the above values, previous slide values, we will get root 2 divided by root pi into integration over 0 to infinity e power minus t dt by under root of 2t. Okay, so root 2 get cancelled. So 1 by root pi into integration over 0 to infinity e power minus t divided by, here we have root t into dt, right? So that is equal to 1 by root pi integration over 0 to infinity e power minus t into, so root t is nothing but t power 1 by 2. So 1 by root t is nothing but t power minus 1 by 2. So e power 1 by root t is nothing but t power minus 1 by 2. So e power minus t into t power minus 1 by 2 into dt, right? So here I am taking plus 1 minus 1. Here I am taking plus 1 into minus 1 because we have gamma function formula. So we know that gamma n equal to integration over 0 to infinity e power minus x power n minus 1 into dx. So gamma n equal to integration over 0 to infinity e power minus x power n minus 1 into dx. Okay. So now which will be in the form of, okay. So after simplification of this one, 1 by root pi integration over 0 to infinity e power minus t, simplify only this part. So that is minus 1 by 2 plus 1. So that will be 1 by 2. So e power minus t into t power 1 by 2 into t power 1 by 2 minus 1 into dt, right? So now which will be in the form of e power minus x power n minus 1 dx. So which will be in the form of integration over 0 to infinity e power minus x power n minus 1 dx. So that is nothing but gamma n. So what is gamma n? N value is here 1 by 2. So 1 by root pi integration, 1 by root pi, this total value is gamma n. So here n value is 1 by 2. So that's why gamma is, the value is gamma 1 by 2. So and also in gamma function, we have one formula. So that is gamma 1 by 2 is root pi. So that's why gamma 1 by 2 is root pi. Root pi get cancelled. We will get 1. So therefore, integration over minus infinity to infinity f of x dx equal to 1. So this is nothing but total probability. So the total probability in the normal distribution is always equal to 1. That means the total probability in the normal distribution is unity. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.